All right. Hi there, guys. My name is Wilfrid, and I'm a senior math tutor. And today I'll be covering 10 questions surrounding algebra and mathematics. A little bit backstory upon myself. I graduated my master with a major in biochemistry and a minor in mathematics. And lastly, if you have any other issues or problems or questions with your homework, tests, or quizzes or assignments regarding chemistry and mathematics, please submit them through OneClass, and we'll get to them as soon as possible. Thank you. So I'm just going to start with the first question. So the first question reads, what is not a real number? Okay, so we have to describe what real numbers are first of all, okay? And real numbers, the short answer is that the real number is what classifies anything on the real number line. Okay, so I'm gonna draw a real number line here for you guys. So here's my line. Sorry if it's squiggly. Okay, so this is our real number line, and in the middle of it we have 0. Okay, so within the real number line, there are a lot of different classifications of numbers. There's a lot of different categories. Okay, so the first category we're going to talk about is what we call natural numbers. Okay, so we have what we call natural numbers. So the natural numbers are our counting numbers. So these are what 1, 2, 3, 4, 5, and so on. Okay. So that is what natural numbers are. They're our counting numbers, right? So on the number line, they would exist on the right-hand side of 0, and they would be like here, like 1, 2, 3, 4. Okay, so those are our natural numbers. Okay, so the next number category of numbers that we want to talk about is called the integers. Okay, so integers. And these numbers are like the natural numbers, except that they include the negative realm of the real number line, right? So we could have like -5, -4, -3, -2, -1, 0, 1, 2. So these are our integers, okay? So dot, 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 and so on, and this goes this way too. So if we were to add this onto our number line, we would have -1, -2, -3, -4. Okay, so the next category of numbers is called our rational numbers. And it gets its name because it is a ratio of two different integers. So they could be positive or negative, but they exist as a rational or a ratio of two numbers. So that could be 3/2. That could be -7/6. This can be like 101/76 or something like that, right? So these are what we call our rational numbers, and they exist in between each of these ticks. So half would be here, right? 3/2 would be here, like -3/2 would be here, 7/2 would be here, right? So these are our rational numbers. They are a ratio of two positive or negative integers. Okay. So our final class or category of numbers on the real number line are what we call irrational numbers. Okay, and these numbers cannot be described as a ratio of two positive or negative integers. And another description about them is that they have a never-ending decimal. So that means that the digits past the decimal continue on going. So a really popular one is like pi, for example. Another one is √2. So these are some forms of irrational numbers, right? And they all exist on the number line, right? So we have like pi, which is here, and √2, which is like around here somewhere, right? So this is what we call our real numbers. These encapsulate all the real numbers, okay? So what is not a real number? We need to expand our dimensions of our real number line, okay? And this is a really helpful illustration to examine what is not a real number. So think of more of a Cartesian plane where the horizontal axis is what we call the real number line. So I'm going to say a real number here. And the vertical axis we're going to call our imaginary number line, okay? So imaginary numbers, they are defined by one thing and one thing only. So we have imaginary number I, okay? So I is the square root of -1. Now, usually you cannot calculate the square root of -1. It will just give you, if you put it on the calculator, it will be an error, right? But mathematicians have come to classify this number, square root of -1, as I. So now we have a different realm of numbers, and these imaginary numbers are not real numbers because they are not contained in the real number plane. So we have, for example, I, we can have 2i, we can have half I, right? So these are what we call imaginary numbers. We have -I, -2i here, right? So we can have a combination of real and imaginary numbers, and this is what we call a complex number. So a complex number has both an imaginary component and a real number component. And if you think about it as a coordinate system, they will be existing in each of these quadrants. For example, let's say that we have a complex number here, and let's say that this is 3. So this number here, this complex number, will be the real component, right? So it will be 3 and I, right? So this is what we call a complex number. And we usually see them as like this. So a complex number can be negative, it can be positive, but it both has a real component plus imaginary component, okay? So going back to the question that was originally proposed, so we're talking about what is not a real number. So we have come to the conclusion that there are two categories of numbers that are not real: imaginary numbers and the complex number. So the junior tutor wrote, real numbers are numbers that can be found in a number line. They include the rational and irrational numbers, the natural and whole numbers, and the integers. Hence, since complex numbers are not found in a number line, we cannot consider complex numbers as real numbers. Therefore, the imaginary number, which is a complex number, is not a real number. So this solution is correct. And for the rest of the lesson, we'll be tackling how to work around these imaginary and complex numbers, okay? All right, let's move on to question number 2. All right, so question number 2 reads, multiply the given expression x squared minus x divided by x squared plus 5x plus 6 times x plus 2 divided by x squared plus 2x minus 8. So there's two strategies involved with this one. We can either just harsh multiply each of these together and just do it like with brute computation, or we can try to factor each of these polynomials on the numerator and denominator and cancel them out as we go. And I think we're going to do that instead. So we're going to factor them first, okay? So we're going to write out, how should I do this? Okay, so I'm going to factor each of these. I'm going to label them 2, okay? So this is going to be 1, going to be 2, and this is going to be 3. So we're going to need to factor all 3 of these polynomials, okay? So let's factor 1 first, which is x squared minus x minus x. Okay, so using my method of cross multiplication, right? So we have to think of the factors of x squared, which is just x and x. It can be negative x, but we're going to keep x and x. Wait, this is actually just x squared minus 2x. What am I doing? This is just x squared minus 2x. Oops. X squared minus 2x. Give me a second. Hold up. Okay, that's fine. So this is just x squared minus 2x, and that equals x times x minus 2. Okay, so we factored it. So number 2, x squared plus 5x plus 6. So the factors for this are x, and 3 and 2, 2x, 3x. Yep, so if we were to cross multiply and add these together, we'll get 5x. So that means that the factors for this are x plus 3, x plus 2. And finally, we're going to factor number 3, which is x squared plus 2x minus 8. And that's going to be x and x, and 4, negative 2. Cross multiply these together, what do we get? Negative 2x plus 4x, which is 2x. So we got the right factors here, so that equals x plus 4 x minus 2. Okay, cool. So now we can rewrite our expression here as the factors instead of this. So it's going to be, our expression is going to be x times x minus 2 divided by x plus 3 divided by x plus 2, or times x plus 2, times x plus 2 divided by x plus 4 divided by times x minus 2. All right, so now we can cancel out the common factors here, which is this, 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 and this. And what we're left with is just x divided by x plus 3 times x times plus 4. And if we were to expand this, we would get x divided by x squared plus 7x plus 12. Okay, so that's how you were to multiply this given expression. You can do it by brute computation, but it would take a lot more work because you're multiplying a trinomial term by a trinomial term. So you'll have a lot of terms that you have to multiply together and then add and then simplify. So by doing this factoring here, we're able to cancel out the common factors and make it a more simple expansion in this case. Okay. So looking at this question here, I believe that the question was misprinted. I believe this should be x squared minus x minus 1 because all the answers have a factor of x plus 1 at the top. So I believe the junior tutor actually assumed that it was x squared minus x minus 1. So I'm gonna say that the solution is still correct because the solutions here are based on the fact that this top numerator is x squared minus x minus 1. So the solution is correct. However, expression of the first term should be x squared minus x minus 1. Okay, so give me a second. I'm just going to pause for a bit. So just give me a minute. It's really hot. Okay. Okay, sorry about that. It's just really hot in my room. Okay, so let's move on to the next question. So the next question reads, how do you factor 8x cubed plus 27? Okay, so we're going to be using the sum of cubes rule to help us factor this. So the sum of cubes rule basically explains that that we can factor a sum of cubes in two different ways, depending on what the sign is. So let me just pick another one. So I'm going to write sum of cubes. Yeah. Okay, so the first one is a cubed plus b cubed. And the factors for this is going to be a plus b times a squared minus ab plus b squared. Okay, so that's the first, I guess, the first part of the sum of cubes. The second one is pertaining to a cubed minus b cubed. That will equal to a minus b times a squared plus ab plus b squared. Okay, so these are the sum of cube rules, and they apply to a cubed plus b cubed and a cubed minus b cubed. All right, so looking at our original question here, we have 8x cubed plus 27. So we need to write it in this kind of form. Okay, so we're kind of there already. We have x cubes, right? But how about 8 and 27? Can they be written in a cubic form? And they can. So we can write 8x cubed plus 27 as 2x cubed plus 3 cubed, okay? And this is where your knowledge of cubic powers comes in, because 3 cubed is 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is equivalent to 27. And 8x cubed is equivalent to 2x times 2x times 2x, because 2 times 2 is 4, and 4 times 2 is 8. And x times x is x squared, and x squared times x is x cubed. So we can write our original expression in this form. And now we can apply the sum of cubes form, right? And by applying it, we see that this can be written as, so a plus b, so we're going to write 2x plus 3 times a squared, so 2x. So a lot of people think, oh, our a is 2x to the power of q, or to the power of 3, which is wrong, right? Your a is going to be what's inside the brackets. So it's going to be 2x squared, so it's 4x squared, minus a times b, so 2x times 3, which is minus 6x, and then b squared, so plus 9. Okay? So this is how we write it. This is how we factor any power, any sum of cubes. Okay. So this solution is correct. You included an equals sign instead of the addition operator. Okay, cool. So everything is clear, so this solution is correct, and we'll move on to the next question. All right, so the next question reads, which pair of complex numbers has a real number product? So in the first question, I described what a complex number is, right? So a complex number has a real component and an imaginary component. Okay. Another thing to cover before we even begin to tackle each of these options is that we know that I is equal to root of -1. So therefore, I squared is going to be equal to root of -1 squared, which is equal to -1. Okay, so this is going to be a very important fact as we try to tackle this question. So this question is asking us that to multiply each of these terms together and see which one only has a real number component. Okay, so we're going to do that for each of them, okay? So first of all, let's do it for A. So for A, we have 1 plus 3i times 6i. So that would equal, if we expand 6i, because 6i times 1 is 6i, plus 18i squared. Right? And we know that I squared is equal to -1, so we get 16 negative 18. So we get another complex number. So this has an imaginary and a real component. So this is not the solution we're looking for. All right, let's look at B. Okay, so B is going to be 1 plus 3i times 2 minus 3i. Okay, so we're going to use cross multiplication, or we're going to use FOIL to expand this. So it's going to be 2 minus 3i plus 6i minus 9i squared. And if we simplify this, we get 2 plus 3i plus 9. Because I squared is -1, so negative, negative, positive. So if we simplify, we get 11 plus 3i, which is not our solution again. Okay, let's look at C. So C is going to be 1 plus 3i times 1 minus 3i. Okay, so if we expand, we get 1 plus 3i minus 3i minus 9i squared. Okay, so if we were to simplify, we have this imaginary component to be canceled, and we're left with 1 minus 9i squared. And I squared is -1, right? So negative, negative is positive. So 1 plus 9, and that equals 10. All right, let's check the last option here. So our last option is 1 plus 3i times 3i. Okay? So this is going to be 3i times 9i squared. Okay? So I squared is negative, so we get 3i minus 9. Alright, so now looking at all our options, we can see here that C is the correct option because it gives us the real number component only. And this brings us to our final, I guess, discovery from this question. So when you're having imaginary, I guess, when you have complex numbers together, or multiplied together, when you multiply a complex number with its conjugate, you'll get a real number component. So in other words, our discovery here, our observation, is that when you have a complex number such as a plus bi, right? So this is a complex number, imaginary and real component here, and you multiply it by its conjugate. So a conjugate is basically has the same magnitude, but the signs are switched. So a minus bi instead. You'll get a squared plus b squared, which is just a real number, right? So this is a very important lesson, and we'll be applying this in our future questions, okay? So other than that, we have found our answer, which is C, and the junior tutor also found the answer, which is C, so this solution is correct. Good stuff. Cool. All right, let's move on to question number 5. All right, so the next question reads, what are values of x is in the solution set of 2 times 3x minus 1 greater than or equal to 4x minus 6? So this is an inequality, and basically an inequality, as I described in previous lessons, they need us to find the values of x where this statement will hold, where the left side will always be greater or equal to the right side. So we already have an issue with this because we see here that there's a variable on both sides. And this makes it very hard to evaluate when this statement is going to hold because there's a variable that will change the right side and the left side all the time. So a general rule of thumb when you're solving these inequalities is that you want to move all your variables to one side and all your constants on the other. And by doing so, you have a better evaluation of what values of x will make the statement true. Okay, so let's try that. So we have 2 times 3x minus 1. And this left side will always have to be greater than 4x minus 6. So the first thing I want to do is get rid of this 2, right? It's the easiest thing to get rid of. So I'm going to divide both sides by 2. Okay? So by dividing both sides by 2, we get this statement. Okay? 3x minus 1 is greater than, so 4x divided by 2 is 2x, and 6 divided by 2 is 3. So we get this statement. Now we want to move this x to the left side and this negative 1 to the right side. So I'm going to I'm going to subtract both sides by 2x, okay? So by subtracting both sides by 2x, I get it rid on this side and move it to this side. So 3x minus 2x minus 1 is greater than negative 3. We still have a negative 1 here, so I'm going to add both sides by 1, and this is what we get. 3x minus 2x greater or equal to negative 2. All right, cool. So now we just need to simplify our left side, which is going to be x is greater than or equal to negative 2. So now we have solved our inequality. So by moving all our variables on the one side and keeping all our constants on the other, we're able to manipulate our inequality to find the values of x, which will make the statement true. So basically, whenever x is greater than or equal to negative 2, the top inequality is always going to be true. Okay? So in other words, let me write out a statement. When x is belongs to the interval of negative 2 and infinity, 2 times 3x minus 1 is greater than or equal to 4x minus 6 is true. Okay, so that's how you solve a lot of inequalities. In the future, they'll probably be a lot more complicated. But yeah, that's how you do it. Okay, so the junior tutor also did that, and they stated what each of their steps were, so this is a good solution. So the solution is correct. Nice job. Okay, let's move on to question number 6. All right, so the next question is covering system of equations, and it reads, how do you solve negative 2x plus y equal 1 and negative 4x plus y equal negative 1? So basically, they're asking for the values of x and y, which will satisfy both of these equations, okay? And if you look more closely, you would understand that these both are line equations. So if you were to think about this graphically, they're actually looking for the point of intersection between these two lines. And the point of intersection is going to be the x and y that will solve both of these equations. Okay, that'll make both of these equations true, basically. And they ask us to use substitution, so we're going to use substitution. All right, so the first thing that I want to do is I'm going to write down our original equations again. So negative 2x plus y equal 1. And the other equation is negative 4x plus y equals negative 1. Okay, so for the first rule of using substitution is that you need to isolate one of your variables for either equation, okay? So I'm going to use our first equation here. I'm going to isolate for y. So I'm going to manipulate it in a way that I move all the x's to one side. So I move the negative 2x to the right side by adding 2x to both sides. So I get this. All right, and I'm going to label this 1. Okay, so now I'm going to say sub 1 into 2. So I'm claiming to take this new equation and sub it into this. So any y will be subbed by 1 plus 2x. So what do I get? Negative 4x plus 1 plus 2x equals negative 1. Okay, and if I simplify this all together, we get negative 2x equals negative 2, and then we get x equals 1. So now we have found our value of x, which will make these two equations be true. However, we still need our y, so I'm going to label this 3, and we're going to sub 3 into 1 to solve for y. Okay, so if I sub 3 into 1, we get y equals 1 plus 2, which equals 3. Okay, so now we have found our point of intersection. Therefore, 1 and 3 is the solution to our system of equations. Okay. All right. So in general, there could be multiple points of intersection, but in this case, we have 2 lines, right? And the 2 lines will always have only one point of intersection. They'll only have one solution that will make both of these equations true. But when you move up to quadratics, or like if you're calculating a system equation between a quadratic function and a line function, you might have 2 points of intersection, right? So you have to be wary. So whenever you're evaluating this, please look at the nature of the functions first, so that you can kind of understand how many points of intersection you have. Okay? So yeah, I'm going to move on. So this solution is correct. Cool. All right, question number 7. So question number 7 reads, what is the quotient of x cubed plus 6x squared plus 11x plus 6 divided by x squared plus 4x plus 3? All right, sorry, give me a minute while I hear some noise, so I'm just gonna take a break here. Okay, sorry about that. All right, so we could use long division to solve this, but we could also use a very clever idea to help find the quotient of this. Okay, so we're going to be using a term called grouping, which is a factoring strategy, which will help us find the factors of our top and bottom functions, I guess. So we're going to first write down our quotient, or our division here again. So x cubed plus 6x squared plus 11x plus 6 divided by x squared plus 4x plus 3. So we're going to group our numerator in such a way that we can factor it, right? So let's look at this, for example. I'm going to rewrite our 6x squared and 11x in a different manner, okay? So I'm going to write it out as x cubed plus 4x squared plus 2x squared plus 3x plus 8x plus 6, okay? And we still have our denominator here, x squared plus 4x plus 3. Okay, so now that we have written this out in a different manner, we're going to rearrange the order of our terms to group it in a different manner, okay? So I'm going to take this 4x squared and this 3x and group it with my x cubed, okay? And this 2x squared is going to be grouped with the 8x plus 6, okay? So if we were to do that, we would get x cubed plus 4x squared plus 3x bracket. So I'm going to signify that I'm grouping them by bracketing up them. And this is going to be 2x squared plus 8x plus 6. Okay, so that's all divided by x squared plus 4x plus 3. So all of these are just different ways of writing a numerator, okay? So now I'm going to factor out x in the first bracket, which gives us x squared plus 4x plus 3 plus, I'm going to factor out 2 in the second bracket, which is going to give us x squared plus 4x plus 3. Oh. Sorry about my lines. I can't draw lines. Okay. So now we can group these in a different way, right? So we see here that this x times x squared plus 4x plus 3 has the same factor as 2 times x squared plus 4x plus 3. So we're going to factor out in the numerator x squared plus 4x plus 3, and this is what we get. Okay, so we got x squared plus 4x plus 3 times x plus 2. Okay. And we get x squared plus 4x plus 3. So this is what the technique called grouping is, right? So you manipulate your polynomial in a way that you have two terms with similar factors. And by doing so, you can factor out those same factors, and you can find the factors of your polynomial instead of using cross multiplication or the quadratic formula, right? So here, by using this very clever idea, we notice that the numerator and the denominator have similar factors, which is x squared plus 4x plus 3. So we can cancel both of these out, and all we're left with is actually the quotient of our original expression, x plus 2. Okay, so this is how we use this clever idea of factoring and grouping to find our quotient instead of just doing long division. In fact, long division could work here, and you probably will get the same answer, but it'll save you a lot more time. So this is not usually a technique that's taught, but whenever you're doing this long division, I guess just try to recognize, is there an easier way for me to do this before I enter into the process of long division, right? So the junior tutor, they did the same solution. All they forgot was to include an x squared here, and this is why it threw me off in the beginning. But other than that, this is the correct solution. So the solution is correct. However, in your first line, you wrote 2x instead of 2x squared. Okay, there. All right, let's move on to the next question here. All right, question number 8. So in the previous questions, I talked about what a conjugate was, and we're going to be using the conjugate to help us solve this question. So this question reads, how do you simplify 3 minus 2i divided by 3 plus 2i? Okay, so we're going to use the idea of a conjugate. So let me explain to you guys again how the conjugate applies here. So we want to get rid of the complex number in the denominator. That will help us simplify our solution here. Okay, and before I told you guys that a plus bi times its conjugate, a minus bi, equals a squared plus b squared, right? So it gets rid of the imaginary component altogether. So we're going to use the same principle to help us to simplify. So first, I'm going to write down my expression here. And we're going to multiply this by 1. Okay, so multiplying it by 1 will give us the same answer, right? So I'm going to rewrite this 1 in a different manner. So 3 minus 2i, so this is our original expression here. So I'm going to rewrite 1 as the division of the conjugate of the denominator, which is going to be 3 minus 2i over 3 minus 2i. Right? So this is still equal to 1, right? So we're not changing anything yet. So this is a valid way of manipulating our equation. However, as we multiply this together, we notice that this denominator now is going to be 3 squared plus 2 squared, right? So by doing this, we get 3 minus 2i times 3 minus 2i divided by 9 plus 4. So let's expand the numerator here. So we have 9 minus 12i, I believe, and then plus 4i squared. Okay, divided by, I'm going to simplify the denominator, which is 13. Okay, and now we're going to, so I squared, like before, we know that I squared is equal to negative 1. So by doing that, we know that this is going to be negative 4, and we get 9 minus 4 is 5, minus 12i, divided by 13. Okay, and to rewrite this, we're going to rewrite this in its complex number form, which has a clear and real number component and an imaginary component. So this will equal to 5 over 13 minus 12 over 13i. So we have simplified this beginning expression by getting rid of the imaginary components and the denominator and simplifying it in a way that the real number component and the imaginary component is very clear to us. So this solution is correct. Good work. Okay, cool. All right, so the next question reads, what is the discriminant of 3x squared plus 6x plus 5, and what does it mean? So in previous lessons, I talked about what the quadratic formula is. It's basically a different method of finding the zeros of a quadratic equation or a quadratic function when you're unable to use factoring or grouping or any other technique. And so it finds the values of x which satisfy the quadratic equation through this formula. So negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, where this is the quadratic formula, ax squared plus bx plus c, where we use the coefficients a, b, and c. Okay, so the discriminant is found within this quadratic formula, and the discriminant d, is equal to b squared minus 4ac. So the discriminant is used as a test to evaluate how many solutions or zeros does a quadratic function have. So we're going to calculate our discriminant first, and then we'll describe what this test tells us. Okay. So our quadratic function is 3x squared plus 6x plus 5. Okay, so this is not easily factorable. You guys can try it, but we have determined that is not factorable with our own techniques. So we're going to use our quadratic function, our quadratic formula, and our discriminant. So first we're going to use the discriminant here. So a equals 3, b equals 6, and c equals 5. So our discriminant d is going to be equal to 6 squared, or b squared, minus 4 times a, 3, times c, 5. So we get 36 minus 60, and that gives us negative 24. Okay, so what does it all mean? So when the discriminant is greater than 0, there are two solutions. So there are two zeros. Okay, when discriminant is equal to 0, there is one solution. And when discriminant is less than 0, there are 0 solutions. Okay, so now evaluating our discriminant of our example here, we know that 3x squared plus 6x plus 5 has 0 zeros slash solutions. Finally, what does this mean for graphically speaking? What does this mean, right? So when we talk about a 0, when we talk about a solution, we're also talking about the x-intercept of our quadratic function. So in other words, we can say that our example has 0 x-intercepts. That means that it is floating somewhere in a quadrant and never intercepts the x-axis. Okay. So other than that, the solution is correct. They describe what the discriminant tells us and what the discriminant test is about. They tell us where it's derived from, and they also work through the example to find the correct answer and tell us what this means about the quadratic function. So the solution is correct. This is also a good description. So one last thing to note is that the junior tutor wrote that when d is less than 0, there are two imaginary solutions for the quadratic equation, or there will be 0 real solutions. So you guys can really test this out by actually just looking at the quadratic formula, right? So when your discriminant is less than 0, we have a negative number within this bracket. So we already know that this is going to be an imaginary number or a complex solution because of how the quadratic formula is, how the quadratic formula works, right? So if we look at discriminant equals 0, right, this whole square root is going to be 0, so we don't have two solutions anymore. And if the discriminant is positive or greater than 0, this is not a non-zero number anymore, and this plus or minus sign is going to be functional within our quadratic formula. So that's another way you guys can interpret that. All right, question number 10. How do you simplify 2 plus 5i squared? So I've already talked about I squared is equal to negative 1. So this is going to be just a FOIL method. However, we also have to remember that we're including the imaginary component. Okay, so I'm first going to write out our original expression again. So this is equal to 2 plus 5i times 2 plus 5i, right? So using the FOIL method, we multiply the first term together, which is 4. Multiply the outside terms together, which is 2 times 5i, which is 10i. Multiply the inside terms together, which is, again, 10i. And then multiply the last term together, which is 25i squared. Okay, if we simplify this all together, we get 4 plus 20i plus 25i squared, which is going to be negative 25. If we simplify this all together, we get negative 21 plus 20i. Okay, so that's how you simplify that using the FOIL method. Yeah, that's pretty much it. So this solution is correct. Cool. Finally, we'll move on to our last question of the day here. All right, so I think in question 6, they asked us to solve the system equation using substitution. So here we're going to be using a different technique. and we're going to be using, I don't really know the name of the technique, but I'll describe to you what it is about, okay? So it's not a substitution technique, okay? So, like I said before, we have to find the point of intersection between these two line equations. And so we're going to be using a different technique. So first of all, we're going to line up our system of equations here, okay? So we're going to line them up like this. And we're going to add them or subtract them. We're going to subtract them together, right? So the goal of our subtraction is to get rid of one of our variables, okay? So we're going to transform our first equation here. So I'm going to label this 1 and 2. So for 1, we're going to multiply both sides by 2. So 2x, okay. Let me do this first. X minus 2y equals 3. So this is equivalent to saying 2 times x minus 2y times 2 times 3. So these two are equivalent. I just scaled them up using the factor of 2. So we get 2x minus 4y equal to 6. Okay, so now we're going to label this 3, and we're going to sub 3 into system. Okay. So we're going to take this whole scaled up system of linear equation. We're going to sub it into 1. Okay. So we get here 2x minus 4y equals 6. So 3 and 1 are equivalent. I just scaled them up. And we have 2x minus 3y equals 9. All right, so now if we subtract these together, we see that we get rid of our x term, right? So 2x minus 2x is 0, minus 7y equals to negative 3. Oh, this should be plus. So it's going to be negative y equal to negative 3. And we now know that y equals to 3. Okay, so this is going to be 4. Now all we need to do is sub 4 back into one of our equations and solve for x, right? So let's sub 4 into 1. And what do we get? We get x minus 8 equals 3, or x equals 11. And so like we evaluated in the beginning, we see that these two equations are line equations. So there's only going to be one possible point of intersection between these two. So now we have recognized, oh, we only have one solution. So this must be trending towards the correct direction, right? And if you really wanted to double check, you can sub in x and y into both of the original equations and see that they satisfy the equation. Okay, but we're not going to do that. So we're just going to write our concluding statement. 11 and 3 is the solution to our system of equations. Okay. So this is the alternative method of instead of substitution. And so in the end, there are technically 3 methods of which you can solve system of equations. One, you can use a substitution method, which I taught in question number 5 or 6. You can also graph the 2 lines and just visually identify where they intersect, and that will be your solution. Or number 3, you can use the system of equations cancellation kind of technique to find your solution. And going back to this technique, so when you're evaluating and when you're trying to figure out how to get rid of one variable, you just have to realize, okay, so which variable is easier to get rid of, right? So in this case, it will be kind of hard to get rid of the y variable because you have to multiply both equations by a factor, right? So the closest factor that will be common to both system 1 and equation 1 and equation 2 will be 6, right? So we'll have to multiply equation 1 by 3 and equation 2 by 2 to get 6y and 6y, right? By doing that, you have a lot more work, right? So instead, I multiplied only equation 1 by 2 to get 2x minus 2x. And by doing so, I was able to find our coordinates easier and faster. So the junior tutor here, they used substitution instead, which is technically this is also valid, and they came up with the same solution. Okay, yeah, I'm being stupid. Sorry about that. 3 times 2 is 6, not 8. I must have was looking at this 4. Okay, so this be 9. So actually be 9. Okay, sorry about that. So it'll be 9 and 3. Okay, so this solution is correct. All right. Okay, so that concludes today's lesson. I covered 11 questions surrounding algebra, complex numbers, and a little bit of mathematics. So if you have any other issues with your homework or tests or assignments, please submit them through OneClass and we'll get to them as soon as possible. I hope you guys learned something today, and I wish you guys a good evening. Goodbye, guys.